All right, ladies and gentlemen, welcome to this Athenian Stranger tutorial video where today we're going to be solving all 20 of these balancing equations intro to algebra homework problems. Starting with number 1. Now remember, as we solve these problems, our goal at all times is to maintain balance. Okay, so first draw your vertical line. Let's get in here on number 1. I want to get x by itself. Okay, that's my first step in this process, and I have here positive 6, so I need to do the inverse operation to get rid of that 6, which should be minus 6. In order to keep the equation in balance, because if I take 6 away from the right side, I better go over here and take away 6 from the left side as well. Okay? Now on the right side, these kind of cancel out. But over here, 15 minus 6 is 9. Bring down your equal sign, and this is x. Now your justification for subtracting 6 from both sides is called the subtraction property of equality. You got to know what it means. And then this x equals 9, this is just simplification. Now we do our check. We're going to ask a question in this check. Okay, here's the question. Does 15 equal 6 plus x when x equals 9? Okay, well, if we want to check that, we can substitute the 9 everywhere we see an x, and that's called substitution. So we'll write a new line, 15 equals question mark 6 plus 9, and the justification for this step is called substitution. Well, 16 plus 9 is 15. So I have 15 equals 15. How do I know that this is true? Well, this is called the identity property of equality. Okay, this is important. I'm going to write this one out. This is the identity property of equality. So once I've got all this written down, I'm done. Okay, moving on to number 2. I'm going to start by rewriting this. I need it to be kind of farther away from that 2. So I'm going to write negative 5 over 8 equals n over 8. My goal is to get the x by itself. So remember, I have to keep my equation in balance, guys. Keep that picture of that scale in mind. Okay, so right now, n is being divided by 8. So what is the inverse operation of dividing by 8? Well, the inverse operation would be multiplying by 8. And we're actually going to be multiplying by 8 over 1. This is actually called the reciprocal. Reciprocal of 1 over 8 is 8 over 1. Now, in order to keep the equation in balance, I can't just multiply by 8 over 1 on the right side. I have to multiply it as well on the left side. Right here by 8 over 1. Now check this out. I can cancel these 8's out. 8, 8, 8, 8. I can cancel them out. Now I just have negative 5 equals n. These 1's don't matter. So negative 5 equals n. Well, that's what we think. So how do we prove it? Here's your check. Remember, we're going to ask a question here. And the question is, does negative 5 over 8 equal n over 8 for n equals to negative 5? Does it? Well, let's substitute it in and find out. So I see I've got negative 5 over 8 on the left side. Don't know. And then I'm going to substitute the negative 5 for the n. Negative 5 over 8. And the justification here, this is substitution. I realize I forgot to justify up here. The justifications here would be the definition of the reciprocal and also the multiplication property of equality. And then this is simplification. Okay, so we have negative 5 over 8 equals negative 5 over 8. How do I know that this is valid? The identity property of equality. Okay? Good job. Moving on. Number 3. Draw our line. I want to get n by itself because I want to find out for what value of n is this equation negative 3 equals 6 plus n true. Okay, so what I got to do is I need to reverse this positive 6. So I'm going to subtract 6. But now I'm out of balance because I subtracted on the right. So I need to come over here and subtract on the left. Okay, on the right I can just kind of strike that out. But here, be careful because you've got negative 3 minus 6. This is actually going to be an addition problem with a negative answer. So 3 plus 6 is 9. So it's negative 9. Negative 3 plus negative 6 is negative 9. So I've got negative 9 equal to n. That's what I think it is. But now let's run our check, okay? You ready? Here's the question. Does negative 3 equal to 6 plus n, where n equals negative 9? Well, let's substitute and find out. Negative 3 equals question mark 6 plus negative 9. Well, what is 6 plus negative 9? Negative 9 plus 6 is negative 3. So here I've got this negative 3. Let's go and justify everything. Up here, I use the subtraction property of equality, SPE, and then I simplified. And then here I use substitution, and then I use the identity property of equality to justify negative 3 equal to negative 3. So I proved that there is one and only one number which satisfies our equation, and that's negative 9. Okay? All right, moving on. 4. A over 2 equals negative 8. I've got a piece of advice for everyone watching. Let's rewrite this problem. Let's write A over 2 equals negative 8 over 1. Okay, well, we want to get A by itself. A is on the left side this time. Right now, A is being divided by 2, so I want to do that inverse operation. The inverse of division is multiplication, plus I want to invoke the reciprocal rule. Right now, I've got 1 over 2, okay? Well, to get rid of the 2 on the bottom, I need to multiply by 2 over 1, which is the definition of the reciprocal. Then these will cancel, okay? So that's why I want to do that. I'm going to multiply both sides by 2 over 1 because I don't want to multiply just one side by 2 over 1 and then be out of balance. So I'm going to come over here and do the same thing on the right side. Times 2 over 1. Now, pay close attention here. These 2's cancel, okay? Over here on the right side, you're just going to multiply across the top and across the bottom. So A equals negative 8 times 2 is negative 16. And then 1 times 1 is 1. You don't have to write that. So we think A equals negative 16. We think, but we don't know. Okay? So I'm going to have to write my justifications here. So this was the definition of the reciprocal. Okay? And also the multiplication property of equality. And then this was simplification. Now let's check it. Question. Does A over 2 equal negative 8, where A equals negative 16? Okay. Well, let's substitute and find out. Negative 16 over 2. Does that equal to negative 8? Well, negative 16 divided by 2 is negative 8. I'm going to make a little. So I've got negative 8 equal to negative 8. Yeah, these are equal to one another. And I can prove that by invoking the identity property of equality, IPE. This step here where I substituted in, I should probably justify that by saying substitution. Okay. Alrighty. Number 5. N minus 7 equals negative 6. We're really asking for what values of n is the expression n minus 7 equal to negative 6 true. Okay, remember we're going to keep everything in balance when we do this. So I want to get n by itself, guys. I want n all by itself. What do I do here? I've got negative 7. What's the inverse operation of subtraction? Addition. Let's add 7 to both sides. Remember, if you have something, negative something plus itself, and you know it's going to be 0, you could write that, but you don't have to. You can kind of do this. Bring down this n. N equals. Now be careful here. There's a little alligator right here. You got negative 6 plus 7. Negative 6 plus 7 is positive 1. So n equals 1. It's really, we don't know. All right, is this true? If n equals 1, is the equation n minus 7 equal to negative 6? Is it true? So we're going to ask that question now here in our check. Oh, and I got to justify. So this is the addition property of equality and then simplification. Okay, let's do our check. We're going to ask the question. Does n minus 7 equal negative 6? Where? That's what this semicolon means. The semicolon means where. Where what? Where n equals to 1. Okay, well, let's substitute and find out. So instead of writing n here, I'm going to write 1 minus 7. Does that equal to negative 6? This is substitution. Well, what is 1 minus 7 here? 1 minus 7 is negative 6. So write negative 6 equal to negative 6. Is that true? How do we know it's true? With the identity property of equality. That's how I know it's true. So notice how I've justified every step of the way. Something I realize I forgot to do every time is every time I get this check right, I want to go ahead and do check, 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 and check, check. Because I'm definitely sure, I've proven it, I've justified it, that I'm right. Because I want to celebrate that. Okay, negative 9n equals 9. The real question is, for what values of n is negative 9 times n equal to 9? So here's what you do. Little thing here. Little sidebar. Negative 9n can also be written negative 9 times n. Okay? So I want to do that step. I'm going to rewrite this. Negative 9 times n equals 9. And this is just, my justification here is just rewriting. I didn't really do anything. But now I can do the inverse operation of multiplication. What's the inverse operation of multiplication? That's going to be division, folks. So here's how you write that. We're going to divide. Remember, I have to keep the equation in balance. I can't just divide out the negative 9 on the left side and be done. I've got to come over here and divide it out on the right side. Otherwise, this checkbook won't balance up. Okay? Cancel, cancel. Now I've got n equals, and what is 9 divided by negative 9? Well, 9 divided by 9 is 1. 9 divided by negative 9, that's a positive divided by negative. That's a negative. So 9 divided by negative 9 must be negative 1. Okay? Well, let's see if that's true. First, let me justify it. This was the division property of equality. And then this was just simplification. And I want to write just sim there. And now I'm going to check it. Is it true that negative 9 times n is equal to 9? When or where n equals negative 1? Is this true? Let's substitute and find out. Remember, you can write negative 9n as negative 9 times n. So I'm going to substitute in negative 1. Do like this. Negative 9 times negative 1 equals question mark equals 9. Well, remember, a negative times a negative is a positive. 9 times 1 is 9. So negative 9 times negative 1 is positive 9. So 9 equals 9. This was substitution here. And this is true because of the identity property of equality. Identity just meaning 9 equals 9 is a true statement. So I can go ahead and give my double checks there. And remember what the answer is in all these cases. I feel like, there's a risk we're going to lose something here. I want to make sure you understand. When you're doing most algebra tests, the answer to number 1 would be 9. The answer to number 2 would be negative 5. The answer to number 3 would be negative 9. The answer to number 4 would be negative 16. And the answer to number 5 would be 1. And the answer to number 6 would be negative 1. Okay, this stuff down below, right here, this is checking. I'm checking the work down here, okay? You still have to do that, but that's not the answer to the question. That's the algebra part, though. Okay, moving on to number 7. For what values of n is negative 8 times n equal to negative 32? Okay, so I'm going to start by rewriting negative 8n as negative 8 times n equals negative 32. This is just a rewrite. Okay, what's next? Well, I need to do the inverse of multiplying negative 8 times n. So I better divide, right? I'm going to divide on the left. I want to get the n by itself, so I better divide out that negative 8, right? Well, now I'm out of balance, so I better go over here and also divide by negative 8, right? Right. Remember, you can do this, and that's the whole point. And now you got n equals negative 32 divided by negative 8. Well, guys, 32 divided by 8 equals 4. A negative divided by a negative is a positive. So negative 32 divided by negative 8 equals positive 4 as well. Okay? So I'm just going to write 4. So I actually think this is the answer, right? N equals 4. But let's check it. We got to prove it. And I got to make sure I write the division property of equality. And then this is simplification here. Let's check this. Is it true that negative 8n equals negative 32? And I want to write where what? Where n equals 4. Okay, there's my question. Is that true? Well, let's substitute and find out. Remember, negative 8n is negative 8 times n, so I can do negative 8 times 4. And this should equal negative 32. Does it? It's a question. Well, negative 8 times 4, negative times a positive is a negative. A negative times a positive is a negative. 8 times 4 is 32, so negative 8 times positive 4 is negative 32. And does that equal negative 32? Yeah, it does. And how do we know that? By the identity property of equality. And this was substitution right here. Y'all are doing great. You're keeping up, doing great. Now on number 8 here, I gave most class periods this heads up. You got x minus negative 3. I would just join these together as a big plus because you have a negative, two negatives together like that. Think about this. X minus negative 3. Man, that's just begging to be turned into a plus sign, okay? So, I want to get x by itself. What do I do with this positive 3 right here? I have to do the inverse operation of addition. What's the inverse operation of addition? Subtraction. So I'm going to minus 3. Am I done? Well, only if I want to get it wrong. Now I'm out of balance, right? I took 3 paper clips off the left side. Now I need to take 3 paper clips off the right side. And this is subtraction, so this is subtraction property of equality. What's left? Well, this cancels. And now I've got x equal to, be careful here, negative 1 minus 3 is going to be a bigger negative number, ladies and gentlemen. So I got negative 4. That's what I think. Let's check it. Here's my question. Does x minus negative 3 equal negative 1? Where x equals negative 4? Is this true? Well, let me try plugging in using substitution, negative 4 for x. So instead of x, I'm going to write negative 4 minus negative 3 equals negative 1. Is this true? Well, remember, this is a positive here. So what is negative 4 plus 3? Negative 1. So I'm going to write negative 1 equals negative 1. How do I know this to be true? Okay, so this is substitution. This is the identity property of equality. Okay, boom. Guaranteed to be right, okay? So what you've proven down here is that x equals negative 4, okay? That negative 4 is the sole value that satisfies this equation. It's the sole solution. Okay, we're going off the page. Number 9, v plus 10 equals 14. Well, we are trying to get v by itself. So I've got v plus 10. What is the opposite of plus 10? Minus 10. But now I'm out of balance, so I better go over here and do minus 10 as well. Remember, you always want these to be mirrored on both sides of the equal sign. This cancels. Now I got v equals. And what is 14 minus 10? 4. So I believe that v equals 4, but how do I know v equals 4? Well, I got to check it because I don't know it yet. The question is, does v plus 10 equal 14? Where v equals 4? Well, let's use substitution to find out. I'm going to put 4 for v. 4 plus 10 equals to 14. This is justified by substitution. This was the subtraction property of equality, and this was simplification. All right, well, what is 4 plus 10? 4 plus 10 is 14, and 14 equals 14. How do I know that? By the identity property of equality. Okay, so remember, the check just proves that the sole value that satisfies this equation is v equals 4. Okay, so 4 is the answer, but this is algebra. That's why I need all of it. Moving on, number 10. I got to tell you, I would rewrite this as p over 7 equals negative 8 over 1. That's what I would do. Now, remember what your goal is. Your goal is to get p by itself. So when you see this, you should automatically be thinking of this word, reciprocal. Okay, p over 7 really means 1 over 7 times p over 1. Okay, that 1 over 7 can be pulled out. And the reciprocal of 1 over 7, if I want to do the reciprocal, I'm going to do 7 over 1. And the cool property is when you multiply a number like 1 over 7 by its reciprocal like 7 over 1, you can just cancel it out. Okay? And the whole thing just becomes 1. Because what happens is you have 1 over 7 times 7 over 1. If you multiply across the top, you have 7. Multiply across the bottom, you have 7. This fraction reduces to 1. So that's a cool reciprocal property. So what we want to do here is we want to multiply p over 7 by 7 over 1. But now I'm out of balance, so I better come over here real quick and do 7 over 1 so I stay in balance. Now check this out. These 7's cancel, leaving p by itself on the left side. And now I got to do negative 8 times 7. Well, a negative times a positive is a negative. So my answer is going to be negative. 8 times 7 is 56. So it's going to be negative 56. Now that's what I think it is. But we got to check this, okay? Let's check this. Is it true that p over 7 equals negative 8? Where p equals negative 56? Is this true? Well, I don't know. Substitute and find out. That's what I say. So I'm going to substitute negative 56 for p. And we're going to write negative 56 divided by 7 equals negative 8, question mark? Well, let's see. 56 divided by 7 equals 8. A negative divided by a positive is a negative. Okay, so my answer is going to be negative. 56 divided by 7 is 8, so negative 8 equals negative 8. Is this true? Sure it is. How do I know it's true? It's true by the identity property of equality. And this was substitution here. This was simplification. And this was both the definition of the reciprocal and it was the multiplication property of equality. Moving on. Number 11, ladies and gentlemen. Negative 14 equals negative 8 minus x. Okay. The question is, what value of x makes this statement true? Okay. I'm looking for a value of x, which when I take its negative, and then I add negative 8 to it, it's negative 14. Okay. So I want to get that x all by itself. This is actually somewhat confusing because not only do I want to get that x by itself, I don't even want that negative sign there. I want to get rid of it too. So I'm going to show you guys how to do this. This is maybe a more challenging problem. So first we can deal with this -8. I gotta get this guy out of here. Well, how do I do that? Well, if it's -8 right here, I can add 8, but I better do it on both sides of the equation, okay? What is -14 plus 8? Well, that's just like 14 minus 8, okay? 14 minus 8 is 6. So we're going to write 6, but we're going to write -6 because -14 plus 8 is -6 equals, and then this gets crossed out. This is the addition property of equality, and I have this equal to -x. Okay, so this is where I need to be very clear about something. -x is really -1 times x. Okay? -x is really -1 times x. So this is simplification. And now I'm just going to rewrite this as -6 equals -1 times x. And this is just a rewrite. Okay? Now I need to do the inverse operation of multiplication, which is division. So I'm going to go through and divide everything by -1. Okay? So this one's a little bit harder. Well, these cancel, leaving x by itself on the right side. And -6 divided by -1, well, a negative divided by a negative is a positive. Okay? And 6 divided by 1 is 6, so -6 divided by -1 is +6. This is what I think the answer is, x equals 6, but let's check that. And I'm going to move these notes here because I want to check this problem, but I'll run out of room. So this is my check. Okay? The question is, does -14 equal to -8 minus x, where x equals 6? Well, let's substitute and find out. We got -14 equals -8 minus 6. And is that true? And this is substitution. This was simplification over here. And -14 equals -8 minus 6 is -14. And is this true? Yes, it's true. How do I know? The identity property of equality. Double check mark there. Okay. Number 12 looks deceptively simple. 1 plus p equals 0. For what value of p is the equation 1 plus p equals 0 true? Okay, so now I want to get p by itself. Okay, I need to know what p is. So I got to subtract 1 from both sides. If I just subtract it from over here on the left, it won't be in balance anymore. So I'm just going to subtract 1 from both sides. These cancel out, and I get the p all by itself in one step. 0 minus 1 is -1. And so I got p equal to -1. But how do I know that that's true? Let's check it. Check. Okay? First, we should justify. This is the subtraction property of equality, and this is simplification. Let's check it. Is it true that 1 plus p equals 0 if p equals -1? Let me rewrite this a little bit better. I'm getting kind of sloppy here with the writing. Here's my check. Does 1 plus p equals 0 when p equals negative 1? Okay, is that true? I don't know. Let's plug in negative 1 for p and find out. 1 plus negative 1 equals 0. So I'm adding 1 to itself. This is called an additive inverse. Okay, so here's the definition of an additive inverse. 1 plus negative 1 equals 0. This is an additive inverse. ADDITIVE, inverse. Okay, this is substitution, but it's also the definition of an additive inverse. So we write 0 equals 0. Is that true? Yes, it's true by the identity property of equality. Check, check. All right, moving on. Negative 7 equals v over 4. Okay. Well, the first thing I would do, guys, is I would never write it like this. I would write it negative 7 over 1 equals v over 4. Now, my goal is to get the v by itself. So the first thing I have to do is inverse operation of v over 4. Remember that v over 4 really equals 1 over 4 times v over 1. Okay, so I'm actually going to write that step this time. I'm going to write negative 7 over 1 equals 1 over 4 times v over 1. Well, now I'm going to do the reciprocal. I'm going to multiply by the reciprocal of 1 over 4, which would be 4 over 1. Okay. I want to multiply both sides by 4 over 1. Okay. And these cancel. Over here, I've got 4 times negative 7. 4 times negative 7 is negative 28 equals to v. So I think v is negative 28. Okay, I think so, but I'm not sure. Let's check it, okay? Check. Is it true that negative 7 equals v over 4 when v equals negative 28? Is this true? Well, let's substitute and find out. We got negative 7 equal to negative 28 over 4. I got to go justify all this. So this is the definition of a reciprocal, and it's also the multiplication property of equality. This is simplification. This is substitution. Well, we're at negative 7. Negative 28 divided by 4. Negative divided by a positive is a negative. 28 divided by 4 is 7. So negative 28 divided by 4 is negative 7. So this is true by the identity property of equality. Check, check. Here comes number 14, ladies and gentlemen. My first step is to rewrite it. I've got negative 2 over 7 equal to n over 7. Spencer had a very good trick. He said, what if you just erased this divided by 7 on both sides? N would equal negative 2. And I told him that was a very advanced move. Let's see if he was right. My goal is to get the n by itself. I want to know for what value of n is n divided by 7 equal to negative 2/7. Okay, let's check. Well, the first thing I can do is use the definition of a reciprocal combined with the multiplication property of equality to take 1 over 7 and multiply it by 7 over 1. But I need to do it on both sides in order to preserve balance. Well, check this out. These cancel and these cancel. Now I've got negative 2 equal to n. Look at that. That Spencer trick was pretty sweet. It's a big deal that he noticed that so early on. I'm really proud of him for that. Okay, but we're not sure about this. We don't know if he's right or if our work was correct. So we're going to check it, okay? We always check it. Let's go ahead and ask this question. Is negative 2 sevenths really equal to n over 7 when or where n equals negative 2? Is it true? Well, I got negative 2 over 7 equal to, substitute in negative 2 over 7. Is this true? Well, I got a thing equal to its identical self, and that's true by the identity property of equality. Okay, so up here I used the definition of a reciprocal, and I did the multiplication property of equality, and then I simplified. Okay, here I substituted, and then I used the identity property of equality to prove this. Number 15, 8 equals x over 7. Well, the question is, what value of x? For what value of x, if there are any, does 8 equal x over 7? So let's ask that question I'm going to rewrite it as 8 over 1 equals x over 7. Just makes it easier to work with. Well, I have x divided by 7. I'm going to use a combination of the inverse, the definition of a multiplicative inverse, which is the definition of a reciprocal. I used a term here that I didn't spell out. So I said multiplicative inverse. Okay? That's the same thing as reciprocal. Okay, so as an example, I have 1 over 7. The multiplicative inverse of 1 over 7 is 7 over 1. All right? So sometimes I'll say multiplicative inverse, and sometimes I'll say reciprocal. All right, well, anyway, let's just multiply both sides by 7 over 1. Stop wasting time about it. Okay, on the right side, these cancel. And on the top here, I've got 7 times 8 equal to 56. Only thing on the right is x. So I think x is equal to 56, but I'm not sure, and I'm going to check that right now. Here's my check. The question is, ladies and gentlemen, does 8 equal x divided by 7 for where x equals 56? Okay, let's substitute and find out. I got to justify everything here. This was the reciprocal, and then the multiplication property of equality, and then this was simplification. Here I'm going to substitute. I've got 8 equals 56 over 7. Okay, question mark, but this is substitution. Well, 8 equals 56 divided by 7 is 8. So the question is, does 8 equal 8? Yes, it does. How do I know that? By the identity property of equality. Number 16, ladies and gentlemen. Negative 6 equals negative 6 minus x. So is there any value of x where negative 6 equals negative 6 minus x? I don't know. Let's find out. So first we're going to do the inverse operation of subtraction, which would be plus. I'm going to do plus 6, but I'm out of balance now, so I better come over here and do plus 6, right? Well, check this out. Remember, additive inverse equals 0. And so I've got negative 6 plus 6. That equals 0 on the left. And on the right, I've got negative 6 plus 6 equals 0. This can be confusing because they're both 0, right? They're both 0. And so what you have as an answer is 0 equals to negative x. Okay? Now remember, negative x equals negative 1 times x. So I have 0 equals negative 1 times x. Now I need to do the inverse operation and divide both sides by negative 1. Well, 0 divided by anything, 0 divided by any number equals 0. So 0 divided by negative 1 is 0. These cancel, so I've just got x equals 0. So in this example, I believe that x equals 0. Remember, 0 is a number. Let me justify all this. So first I use the addition property of equality. Then I simplified. Then I used the division property of equality. And then I simplified. Okay? Now what? Let's check it. The question is it true that negative 6 equals negative 6 minus x, where x equals 0? Is this true? Well, let's see. Let's substitute and find out. So I got negative 6 equals negative 6 minus 0. Okay, this is substitution. Well, what is negative 6 plus 0, ladies and gentlemen? Negative 6 minus 0. I've got negative 6 equals negative 6 minus 0 is just negative 6. How do I know this? By the identity property of equality. Okay? So we're sure that x equals 0. Moving on. I've got negative 10 equals n over 8. Well, let's rewrite this as negative 10 over 1 equals n over 8. Okay? Well, definition of the reciprocal or multiplicative inverse. Remember the multiplicative inverse. Multiplicative. I'm not wasting your time. This is an important term to know. The multiplicative inverse. If I have A over B, the multiplicative inverse of A over B is B over A. Y'all get that? So if I have C over D, and I want to take the multiplicative inverse, I get D over C. That's a really important concept. The concept of an inverse. That's just a reciprocal. So here I'm going to use the multiplication property of equality together with the multiplicative inverse or reciprocal property and multiply both sides by 8 over 1. Now watch what happens when I do that. I can cancel out these 8s, which is great news because now I just have to multiply 8 times negative 10. Well, positive times a negative equals a negative. So 8 times negative 10 is negative 80 equals to n. That's what I think. I believe that negative 80 equals n, but we're going to check it. We got to check this. So here's my question. Is it true that negative 10 is equal to n over 8 when n equals negative 80? I don't know. Let's plug it in and find out. We got negative 10 equals negative 80 over 8. Okay, question mark. This is substitution. Okay, this was the reciprocal and the multiplication property of equality, and this was simplification. Now, 80 divided by 8 is 10. Negative 80 divided by 8 is negative 10. So I have negative 10 equal to negative 10. And that is true by the identity property of equality. So we'll give that 2 check marks. Moving on. Number 18. 5 equals 1 plus p. Well, for what value of p is the equation 5 equals 1 plus p true? For what value of p is the equation 5 equals 1 plus p true? Well, we have to isolate p by itself. Okay, I want p by itself. So what do? Well, I need to do the inverse operation of addition. So I need to do the additive inverse of 1, which would be negative 1. So I'm going to do minus 1. But to stay in balance, because this is algebra, I got to subtract 1 on the other side as well. Well, these cancel. 5 minus 1 is 4. So I think 4 equals to p. But how do I check that? And I'm going to justify. This is the subtraction property of equality and simplification. Check it. Is it true that 5 equals 1 plus p when p is 4? Well, let's substitute and find out. 5 equals 1 plus 4. I just substitute the 4 for the p. Let's see here. 5 equals 1 plus 4 is 5. How do I know this is all true? Well, this is the identity property of equality that proves it. Okay? You got to check your answers. We're down to the final 2. So first I'm going to rewrite this as x over 5 equal to negative 7 over 1. Right away, guys, when I see this, I know I'm going to be using the definition of the multiplicative inverse. Remember, that is a over b. If I take the inverse, I get b over a. You just flip it, right? Well, what's going on here is I've got 1 over 5 times x over 1 equal to negative 7 over 1. Okay, let's use the definition of the multiplicative inverse. Flip that fraction and multiply by 5 over 1 on both sides. On the left, I can cancel out those 5s, and all these 1s just go away, leaving me with x. And now over here, I've got negative 7 times 5, which is negative 35. So I think x is negative 35, but how do I know for sure? Only by checking. Okay, let me check this. I'm going to ask the question. For what values, or is it true that x divided by 5 equals negative 7 when x is negative 35? Well, let's just substitute in and find out. Negative 35 over 5 equals negative 7. Is this true? Well, negative 35 divided by 5 is negative 7. So I have negative 7 equal to negative 7. How do I know all this is true, guys? Well, this is substitution, and this is the identity property of equality. Over here, I use the definition of the reciprocal, and I use the multiplication property of equality, and then I simplified. Now on to the final problem. So we've got x minus negative 6. Right away, I'm thinking to do that. Okay. So what is the inverse operation of addition? It's subtraction. Okay, so I'm going to do minus 6. But to keep it in balance, I better do it on both sides. Now I've got x equal to 2 minus 6, which is negative 4. Okay. Now I want to check this work. Is it true that x minus negative 6 equals 2 when x equals negative 4? Is this true? Well, let's substitute and find out. I got negative 4 minus negative 6 equals 2. And I'm justifying that with substitution. Over here, this was a rewrite, and then this was the subtraction property of equality, and then this was just simplification. All right, so here again, I can turn that into a huge plus sign. I got double negatives. Negative 4 plus 6 is 2, and 2 equals 2. How do I know that that's true? By the identity property of equality, okay? Now, we've completed all 20 problems, okay? And here's the work. Guys, if you put in the work here, I really want to say thank you. It makes me really happy when you do the work. And I hope you understand that I'm willing to do the work as well, right? So I sat here and just solved all these live, on camera, kind of speaking. So I'm willing to do the work if you are. That's what I'm trying to say. I will never ask you to do an assignment that I myself am not willing to sit down with you and do. And that's that's what this was all about. So I wouldn't give you so many problems if I didn't know that this skill is so important. Okay, it's so important. It's the foundation. It's like we're building the base of the pyramid. So we've really got to learn how to do this with our eyes closed. Okay? So with that, I'm going to say thank you. Guys, if you haven't already, please give this video a thumbs up. It really helps the YouTube algorithm. And if you haven't already, please consider giving me a subscription and hitting that notification bell so you're always updated when I release new videos. Thank you so very much. Bye.